Algebra I, 10.5e, we're going to subtract rational expressions using the least common multiple for unlike denominators. So we can subtract rational expressions with unlike denominators by finding that least common multiple. We did this when we were adding in the last video. It's the same thing as finding the least common denominator. We find the least common multiple of the denominators, and we figure out what needs to be multiplied to the numerators and denominators to make the denominators the same. It's going to be equivalent to 1, like a 4 over 4 or a 2 over 2, because whatever we multiply the numerator by, we have to multiply the denominator by, and vice versa. So it's going to end up becoming equivalent to 1 because it's the same number over that same number, right? And in a fraction, that equals a 1. Well, after we do that, we subtract the numerators. Then we write the difference over that least common denominator. And here's our example. We did this with addition in the last one. We're going to do it with subtraction now. So we've got 2 over 3y, and we want to take away 1 over 4y. We have to find a place for the 3y and the 4y to meet. Well, they can meet at 12y. And if we factor these out, we get 2 times 2 times 3 times y, right? Here's the 2 times 2, and here's the 3 times the y, right? So what do we have to multiply this by to get to 12y, or this by to get to 12y? Well, this one can be multiplied by 4 over 4 to get to 12y for the denominator, and this can be multiplied by 3 over 3 for this to be a 12y for the denominator. When we multiply the numerators, we get 8 over 12y, and we get 3 over 12y. Now the denominators are the same, we can subtract. 8 minus 3 is 5, we get 5 over 12y. See? That wasn't too bad, was it? All right, so I have a few examples for you. Let's take a look at this one. Now, if you look at these denominators, we have a minus 5 and 5 minus a. These are additive inverses. They're opposites of each other, aren't they? And you remember what we talked about before when these are opposites? We can rewrite this one as negative 1 times a minus 5. So let's say that a equals an 8, all right? And we have 8 minus 5, that would be 3, right? But what if we had 5 minus 8? Well, then that would be a negative 3, wouldn't it? Well, if we multiply it in this direction, a minus 5, with a negative 1 in front of it, we'll get our negative 3. So this will end up becoming the same as this by multiplying this by the negative 1, see, by rewriting it as the negative 1. So check it out. So let's say that a is equal to an 8. Well, then that means we have negative 1 times 8 minus 5, see? And 8 minus 5 is 3, times a negative 1 is a negative 3, see? So when you see the opposites like this, just take one of them, multiply it by a negative 1, and we end up getting a squared over a minus 5. We just copied this one over, and we rewrote this denominator to be a negative 1 times a minus 5, so that it looks like this one, see? All we have to do now is multiply this side of the this rational expression here by a negative 1 over a negative 1. That's our, number over the number that is equivalent to 1. So if we multiply the numerator and denominator by a negative 1, that's going to get rid of this negative 1 in front of it. See? So basically what we did was we were able to turn this around by rewriting it as this one with a negative 1 in front of it. And now to get rid of that negative 1, we multiply the numerator and denominator by a negative 1, because negative 1 times negative 1 makes a positive 1. See? And that gets rid of this negative 1 in front of it. Now we just have a minus 5. And when we multiply this 2 by the negative 1, we get negative 2, don't we? So now, instead of this, now this is what our problem looks like. A squared over a minus 5 got copied over again to here. And we're going to take away negative 2 over a minus 5. See? And now we've got the same denominator, don't we? Sorry about that focus there. Whenever I put my hand in front, it changes the focus. So now our denominators are the same. We can do our subtraction. And we're taking away a negative, so that means we're going to add the opposite, right? So that means we're going to add a positive 2. So we end up with a squared plus 2 over a minus 5. Isn't that something? See how we did that? So that's what you do when the denominators are additive inverses, when they're opposites of each other, okay? You can just rewrite it as this. You can multiply it by a -1 for the numerator and denominator to get rid of that -1 we rewrote it with. And remember to add opposites when you're subtracting a negative, okay? Let's take a look at this one. We've got 9 over x minus 2, and we're going to take away 3 over x. Well, our least common multiple is going to be x times x minus 2. We use the pattern that I taught you in video 10.5b. We're now in 10.5e. And this was the pattern. If you have p over q and you want to take away r over s, what you do is you take p times s minus r times q over q times s, the denominator. See? So we can use this to do this. So that means our least common multiple for our common denominator is going to be x times x minus 2, because it's just them multiplied to each other, see? Q times s. X times x minus 2. Now we have to do the crisscross, don't we? So to do the ps minus rq, we do 9x minus 3 times x minus 2, see? And we've got to distribute this, don't we? We've got a -3 times x, and then a -3 times -2. That's going to give us -3 plus 6, isn't it, when we do the distributive property? And that means we have 9x minus 3x plus 6. We subtract the numerators, keep that same denominator. We have to be careful with our signs when we're doing this, see? And we combine our like terms. We have 9x here and 3x here, right? 9x take away 3x is 6x plus the 6, and that's going to be over our x times x minus 2. See how I did that? We did distributive property there. We combine like terms. Now we're at 6x plus 6. Now all we have to do is factor this numerator. We factor it as 6x plus 1, because that would make 6x plus 6, wouldn't it? And it's over that common denominator, see? And now we're all done. I know this can be really confusing. It's going to help you if you saw 10.5b. If not, you can rewatch this video or just really look at this pattern. We learned how to do adding and subtracting using this pattern with the p over q and the r over the s. It's really helpful. You should put that in your notes. All right? Now, let's take a look at this one. This one looks kind of weird, and I know you're going to come across these. We have an x plus 4 over x minus x over x plus 4. Look, it looks like they're just flipped over versions of each other, like the reciprocals, aren't they? Well, our least common multiple, the common denominator, is going to be x times x plus 4. We're going to use our pattern here, q times s. So we're just going to do this times this for our common denominator, all right? And now we're going to have to do the crisscross, aren't we? We're going to have to do ps, p times s, minus r times q. So that means we're going to have x plus 4 times x plus 4 minus x times x, right? Following this pattern? So now we've got x plus 4 times x plus 4 right here, and we're going to subtract x times x, okay? Well, we got to FOIL this, don't we? And look, x times x, that's x squared, isn't it? See that? So we have x squared is what we're taking away right here. And when we FOIL this, we get x times x is x squared. X times 4 is 4x plus 4x. And 4 times 4 is 16. So now we FOILed that. And if you don't remember how to do that, that's going to be in the description, okay? But really by now you should know how to FOIL. You go first, and then this one, and then you do this 4 times the x, and then the 4 times the 4, okay? So there's 4 things to do when you FOIL. It stands for first, outer, inner, last, all right? And we come up with this. And we have to combine the like terms, don't we? But we have an x squared minus an x squared. So that cancels this guy out, doesn't it? That creates a zero pair. And we end up with just 4x plus 4x, which is 8x, plus 16 over our x times x plus 4. See? Now what we have to do is factor this numerator. And how can we factor that? Well, it could be 8 times x plus 2. That would make 8x plus 16, wouldn't it? And our simplified answer is 8 times x plus 2 over x times x plus 4. And we're all done. All right? So do you see how I used this pattern and how useful it was when we were doing this? You should really have that in your notes if you don't, okay? Because it's really going to help you. And you can also do it for addition. You just put a plus sign here and a plus sign there, and that'll work, okay? All right, so our next video is going to be 10.6. I'm going to talk about how to solve rational equations. And if you want to see the previous videos for how to add unlike denominators using that pattern like I just showed, or adding and subtracting rational expressions with like denominators, or how to multiply or divide them, or how to find the least common multiple, or just how to factor and FOIL. All those links are going to be in this description, okay? And still have my cold. I don't know if you can hear it, but my voice just doesn't quite sound the same. And it's been rough. I'm doing my best to make these videos for you. I hope you're doing all right. And I'll try to do at least one a day. I usually used to do more than that when I was feeling better. But I'm trying to move forward for you, okay? So good luck. If you had trouble, watch the video link, the videos that are linked in this description. And I'll see you next video. Bye.